Hello, welcome to my channel. Today we are going to discuss about the designing of 3-bit synchronous counter using T flip-flop or JK flip-flop for a random sequence. Okay, for example, if you are given with a sequence of 0 to 2 to 4 to 6 and we have to loop through the sequence and build a 3-bit counter, we are going to start off with the present state truth table and the next state truth table. QA, QB, QC is the present state. Present state means if we are at 0 and the next state will be 2, as we have shown with the arrow. QA2, QB2 and QC2, this is the next state. So we are given with 0 2 4 6, which is the even numbers. We are going to write it here at first. 0 2 4 6. At the present state we are at present we are at 0, so the binary value of 0 is 0 0 0. The next state, which is 2, the next state is the 2 next stage, so we are going to write the binary value of 2. When we are at 2 now, this is now the present state 2. Our next state will be 4 because we will be shifting from 2 to 4, so the next state will be 4. The binary value of 4 is 1 0 0. Now if we are at 4 now, the next state will be 6. The binary value of 6 is 1 1 0. If we are at the present state of the counter is 6, the next state will be 0 because we will be looping through the sequence, and the binary value of 0 is 0 0 0. And what about the rest of the values? 1 3 5 and 7, because it's 3-bit counter and the sequence goes from 0 to 7. The values for 1 3 5 and 7 will be null, or in other words, it's don't care. So 1 3 5 and 7, they will be included in the K map, but still they are null values. They don't have a next state. This is our first step. The next step is to make truth table for T flip-flop. The truth table of T flip-flop works based on toggling. So what is toggling? Toggling is shifting values. So if the present state is 0 and the next state is 1, there is toggling, means it changed from 0 to 1. The value will be 1. The value of the T flip-flop truth table will be 1. The same thing for 1 and 0. If the present state is 1 and the next state is 0, there is toggling, so it will be 1. If the present state is 0 and the next state is still 0, there is no toggling, there is no change at all, therefore the truth table will be 0. Same thing goes for 1 and 1, 0. So TA, TB and TC. Now let's look at QA and QA2. QA is 0 and in the next state QA2 is still 0. Was there any toggling? No. Therefore TA will be 0. For QB is 0 and QB2 is 1. There was toggling, therefore TB will be 1. For TC, there will be 0 as well. Now let's look the next one. QA is 0, QA2 is 1. There was toggling, so 1. For TB, it's 1 and the next state is 0. Was there toggling? Yes, so 1. QC is still 0, so 0. And if you continue this 0 1 0, toggling, there is toggling, 0 0, no toggling. Null for 1 3 5 and 7 because they don't have any next state. So the second step is over, which is the truth table for T flip-flop. The third step is making K map using this truth table. So the first one is TA. Zero 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 1 1 1 1 0. So for 0 0 0, which is 0 0 0, TA is 0, therefore we put 0. For 0 0 1, for 0 0 1, TA is null, so we put null. For 0 1 1, 0 1 1, it is still null. For 0 1 0, 0 1 0, TA is 1. For 1 0 0, 1 0 0, which is 4, TA is 0. For 0 1 0, TA is null, it's null. And 1 1 0, 1 1 0, TA is 1. So to make truth table, we look at the present state. Don't look at the next state, just look at the present state. For 0, TA is 0, 2, TA is 1. For 4, TA is 0, and 6, TA is 1. Now let's do the same thing for TB. For TB 0 0 0, TB is 1. For 0 0 1, TB is null. If these are all null, TB will also be null, because it's the same. All the TA, TB and TC are null for these 4 binary values. For 1 0 0, 1 0 0, which is 4, TB is 1. For 1 1 0, for 1 1 0, 1 1 0, TB is 1. For 0 1 0, 0 1 0, TB is 1. Now let's make for TC. Now let's use the grouping method of K-map to find the expression for the terms TA, TB and TC. At first we can group these 4, and if we look, the term QA changes. QB is same because it's 1 and 1. QA is 0 and 1, it changes. QC is 1 and 0, so the only term that doesn't change is QB. So TA is equals to QB. So for TB we can 1 2 3 4 5 6 7 8. If we do this, there will be only 4. We need the maximum, so we take the whole thing because it's 8. So therefore TB, when we take the whole thing, TB will be 1. For TC, there's no 1 at all, therefore TC will be 0. Now we got the expressions for each term. Now using these expressions, we are going to build our counter design. As a 3-bit counter, we need 3 counters: 1 2 and 3. Because it's a synchronous counter, we're going to provide the clock for each. TA, TB and TC, QA, QB and QC. This is the MSB, this is the LSB. So for TA, the TA will be connected to QB, so the output of the second counter, which is QB, will go to TA. TB is 1, and in electronic terms 1 means 5 volt, which is VCC. Therefore TB will be connected to plus 5 volt or VCC or 5 volt. For TC, TC is 0. In electronic terms 0 is ground, so TC will be grounded. And the same design is for JK flip-flop. For example, instead of T flip-flop, we use JK flip-flop. We just short J and K. We just short J and K. but the design remains the same. And this is the final design of 0246 sequence counter. Thank you.